All right, so we're going to start now. Um, Today is our last lecture of this lecture series, Schiz and Leg Symbiosis. And first of all, I want to thank everybody to be here. And also I want to thank everybody that took the time of the days the past 3 weeks to listen to our great lectures and participate in the following discussions. I also want to thank the rest of our team who made all of this possible, as well as the faculty of the KIT and our sponsors. Now to the interesting part. It is my great pleasure to introduce Philippe Rahm as our lecturer today. He is a Swiss architect, principal of the office Philippe Rahm Architects based in Paris, France. His work, which extends the field of architecture from the physiological to the meteorological, has received an international audience in the context of sustainability. His recent work includes the first prize of the Farini competition in Milan in 2019, the Central Park in Taichung, Taiwan, completed in April 2020, the Agora of the French National Radio in Paris, an exhibition architecture for Luma Foundation in Arles, France, and he has held professorships at GSD, Harvard University, Columbia, Cornell, and Princeton universities. So we're really excited for this lecture today, and enjoy.
Thank you. Okay, thank you very much for the invitation. So I will share my screen. Okay, so I will present my work, and I will try to show some condition about architecture today. So sorry. So the first point is this link with climate. I think in reality we can say that climate is the cause of architecture. This is the aim of architecture, the condition and the means of architecture. And so what I mean by the cause, this is a sentence from Vitruvius in his treatise, and he say that architecture is the art to transform the space when it's too hot or too cold to suit to the body temperature in reality. Why we need really architecture? Why we are building something? It's because we cannot live in the snow, you know, with the in the coldness, and because of our bodies need to keep the temperature of the body always at 37 degrees. And so the first reason of architecture is to create a shelter to block when it's too hot, to block the sunlight, or to create a kind of microclimate around the body where you can reproduce a kind of perpetual spring, you know, a comfortable 20 degrees Celsius temperature around the body when it's very cold outside or when it's raining. And so this is really the fundamental reason of architecture, the cause of the construction of buildings. And I think it's quite very important to remember that today, because we have sometimes we are losing, you know, the fundamental reason of something, and so to come back to this climatic reason is something that is very important. And then so we can sorry, I don't know what's happened.
Welcome back.
Yes, sorry. Okay, so I will continue. So now so now the architecture is also, the climate is also the aim of architecture. This is another sentence of Vitruvius. So fire, and you know, you create a fire, and then the people arrive, and so it's becoming like the beginning of architecture. So this is really the aim of architecture, is to transform the climate. You know, when it's cold, you create a fire, and so the people are coming around the fire. This is Peter Sloterdijk is talking about thermosocialism, also about that. But this is like the fact that you are transforming a part of the wall with a climate that fit to human body. And then in Alberti, this is also this origin of the house. So first you create a shelter, a roof, and then you have the wall, and the roof is here to block the sun or the rain, and then you need a wall to support the roof, and you understand that the roof creates a protection against the cold wind, and so this is how we are doing architecture. So the aim of architecture is to transform the natural climatic condition to make them inhabitable. And then the condition of architecture today. And the condition today is linked to global warming. So it means that the cause of architecture is climatic. The aim of architecture is climatic, and the condition today is also climatic. Why? Because we are living today in this global warming period. This is something that of course, you know, but the temperature is rising since the beginning of the Industrial Revolution. So the beginning of when we start to emit CO2 by burning coal and then gas and petroleum, that produce emitting CO2. And so this was the real measurement of the temperature on the planet, on the atmosphere, and we can compare with the CO2 emission that we can also measure since 1950. We can have a real measure of the CO2 quantity in the atmosphere that is more than 400 ppm today. And before it was in ice core, we can measure also the quantity of CO2 inside the atmosphere. So there is this link between CO2 emission and global warming. And this is that we know from Joseph Tyndall, Joseph Tyndall in 1850, he showed that the CO2 is transparent for the inside the visible, but it's opaque inside the infrared. And this is what's happened. During the day, the Earth receives some heat from sunlight, and then it starts to heat up the planet. And then during the night, it re-emits some radiation, but this is no more inside the visible and in the same spectrum. It changed the spectrum and it's re-emitting into infrared. So because these infrared wavelengths are corresponding to the opacity of the CO2 molecule inside the air, so it starts to create a global warming. So this is this phenomena. We can see here more precisely the emission of the Earth planet. This is a spectrum that is re-emitted by the planet in the infrared. The visible part is here, so it's far infrared. And here, this is absorption of the CO2. And so altogether, it creates this global warming, because this is the opacity here. Here, this is the opacity of the ozone and some other gas, methane here, that is creating the global warming. So the consequence of the global warming is what we all know today, the effect of environment, and then some perturbation on the human occupation of the Earth with some different trouble that will grow with global warming. So what are the conditions at the architecture scale? We have to understand that the CO2 emission at the global scale, this is a repartition of the CO2 emission. We can see that buildings are producing 39% of the CO2 emission. So we are talking, in France, for example, the people was talking like a few years ago a lot about airplane. Airplane is 2%, so it's okay, but building are 39%. So it means the architects are really on the front line to reduce the emission of CO2. So as architects, we have really, we are becoming political too, because we need to do something in our field, because the Earth is the most have the most responsibility for creating global warming. Then, if we look where, when, and where it's producing CO2, there is a new study that was published this year from Graz University, and they did on the 600 building some studies, about the repartition between building operations. So when you burn fossil energy to heat up your house for the radiator or the hot water, it's represent a large part of the CO2 emission. The material, if it is in wood or in steel, it's also producing CO2, but it's 1/4 of that. So we can see here, this is quite interesting. This is what's happened today. So here, this is the embodied carbon, so it's linked to the material. So it's why if you do a wood building or a concrete building, you are only working in this part. And if you are doing something about thermal insulation, or if you are dealing with all the technique of the operation of the building, you are working in these large things. So with Passive House and Minergie in Switzerland or Passive House in Germany, of course, this quantity here has decreased. We can see here, the new standard. So this is like the Minergie Passive House standard here. And we can see that the old one, the official one, that are decreasing a lot. So it means that at the end, in the future, we have the emission of CO2 are half coming from material and half coming of operation, because of the very well thermal insulation that is in the new regulation. So, but just to explain what's happened, before we are, or still today, we are burning fossil energy, so it produces CO2. And in the future, we need to change and to use only renewable energy. So this is the energy transition that we have to do. But this energy transition will take time. Maybe it can be more fast, but people are talking about 30 years. But of course, I'm sure that it can be more fast. But why? Because today we still use the energy that we are using. This is also a global calculation, because in Germany, there is more use of coal, for example, for producing energy. And so at the global scale, it represents 85% are still coming from fossil energy that produce CO2, and only 10 are renewable energy, and nuclear are that. So it means in the future, everything should become renewable energy. But because today 85% is still coming from the fossil energy, we have to decrease the consumption of energy. So there is like two steps. First, we have to decrease the consumption of energy, then we have to change to renewable energy, and then we can use energy as we want in the future, because it will be no more energy that is producing CO2. So this is this Minergie Passive House standard that with 20 centimeters of thermal insulation and ventilation and air-proof membrane, things like that. And so in the end, we can reduce a lot, and we can work on this operation part to reduce the CO2 emission, and in order to reduce the global warming. So now we understand that, okay, the cause of architecture is climatic, the aim is climatic, the conditions today are also climatic. So what about the tools for doing architecture? And when we are talking about tools in architecture, about composition, about form, about material, what kind of decision we can make, when you choose a form for the building, or if you choose a material. And the two strategies that we have today are more like geometrical strategy. We use a square or rectangle, or we like a form, and then we use addition of form of square, you know, for doing a composition. And then when you choose a material, you choose it also through some cultural reference. But in reality, why we cannot also change this way of choosing material, of choosing form through climatic parameter, and to say that the means can becoming climatic. So this is the idea of meteorological architecture, to say, okay, the type of composition, the composition will be no more coming from geometry, but will come from meteorology, from climatology. And so convection can be the new symmetry, or conduction can be the new alignment, or evaporation can be the new addition, you know, and all these elements can create some form. So now I present some project linked to that to show how the climatic phenomena, the physics of the meteorology, can create some form and give some help for deciding what type of material we can choose. So the first is about convection. This is a project for an apartment. And in this project, we start from two problems or two states, yes, two issues. The first one is because we want to reduce the energy consumption to decrease the emission of CO2. So the best thing is to reduce the temperature inside the house. And this is a Swiss standard, but it's come from Germany. It was something that was established around the 1950s, 70s in Germany. This is to say that, okay, when you are naked and you have some water on you, like in the bathroom, so you need higher temperature, like 22 degrees Celsius. If you are in the bedroom, you are under the blanket, so it can be only 16. And the living room, you are motionless in the sofa, so it can be 20. And you understand, for example, if in the bathroom it's only 16 degrees Celsius, when you go out of your bath or your shower, it will be too cold and you become cold. So this is like some minimal minimum data about temperature. And the goal of this figure is to reduce the consumption of energy, because if we heat the bedroom at 16 degrees Celsius and not at 22, we economize 6 degrees Celsius. So at the end, you know, if you multiply by all the bedroom in Germany, you know, you will economize a very big quantity of coal, you know, and you will reduce that. So this is like like a starting point. The second element is the convection. You know, the convection is the fact that when the air is becoming more hot, you know, it's become less dense, and so it become more light, and it raise to the top of the room. And so this what you can see here, this line, this is what's happened in a normal apartment. You know, this line represents the temperature. So it means here at the foot level, it can be 16 degrees Celsius. And then it can be 30 degrees Celsius at the top of under the ceiling. This is something that is quite strong. And so it means all this, you know, because we are living down, you know, on the floor, it means that we are losing a lot of energy by heating under the ceiling, and nobody are living under the ceiling. So you have a large mass of air that is very hot, and nobody use it, you know. So it's a loss of energy because we are not heating. And then there is also the fact that sometimes we are cold in the foot, in the feet, you know, and so we turn on the radiator, but in reality, all the heat go under the ceiling, and we still are cold on the feet level. So this is what's happened today. And so this is like thermal representation of a section of a room. So it's colder down and warmer up. So from that, we start to say, okay, we will use this Swiss recommendation, and we will use this Archimedes law of convection, of atmospherical convection, and we will start to design the section linked to that. We say, we made a lot of projects based on this principle, but just to show with this section, we say, okay, here it's 22, this is more hot, and here it's more cold, and then it starts to create inside the atmosphere of the house a kind of variation of climate, and we place inside. We can see, okay, we have we can place the different program linked to the different temperatures. So close here, we can have the bathroom, and we can have the bedroom here, the kitchen, the living room that find place according to the temperature. So this is what we make in this apartment in a very simple way. So we know that it's more hot here and more cold on the floor. So we start to place the program linked to the temperature. So we place the bathroom here next to the ceiling, and the kitchen down, and also the yeah, it's just a funny decision about the sofa. The sofa when you are alone is a little higher than the sofa where you are two or three, because you are sharing the human warmth, you know. So it means it can go down, and then very down we have the bed there. Then there is another phenomena. It's evaporation. This is you know, we need to renew the air inside the apartment because we are producing moisture by breathing, and it's depend also of the activity we have if we are sleeping, we produce only 40 grams during 1 hour. If we are in the normal way, in the normal position, we are producing 150. If you take a shower, you are producing a lot. And so it means the ventilation should be, you know, if you want to not to introduce so much new air in the house in order to reduce the heating of the new air that can be cold in the winter. So you will reduce the quantity of air by introducing first in the bedroom, because there is less humidity, and then it go to the living room, and then to the bathroom. So it means that there is a kind of wind inside the house that is linked to ventilation, but it can, and you understand that, you know, it's not good to that the wind is always in this direction and not in this direction, because you don't want that the bathroom moisture go to the living room, or the toilet go to the smell odor go to the living room or bedroom. So this is like what's happened. So in the section we do something like that from the area here, and so this is like the wind is going like that. So this is some view of the apartment with this. You know, we use the verticality of the space for placing the different function inside. Here we can see the ground of the bathroom. We have a grid that let always the air going through. You know, we don't have to block the air, so the air have to move freely everywhere. And so this is some image of that. We can see here the shower, and that is on the top of the kitchen. and yeah, some view of the apartment. Okay, now another project based on radiation. So all radiation can become the design tools for doing the plan of the project. This is an exhibition space for the Luma Foundation in France. So this is our project was made in a building, existing building of 2,700 square meter here, with skylight that is here, and because it's to exhibit some artwork, the idea is to say, okay, where we will place the artwork linked to the light, because if we place the artwork in a bad place, it means in a too dark area, so we will need to add some electricity lighting, so we will consume some energy for lighting the artwork. And also it's linked in reality to the preservation, the conservation of the material. For example, if you have photographic paper, you need to have only 50 lux, not more, because it will destroy the paper. Or the same, and oil paint, for example, can receive 200 lux. And so it means that we can place different type of artwork on different location linked to the light intensity. And of course, in the darkness, you will exhibit some video, for example, and in the very bright light, you can exhibit a contemporary artwork that will be that is not damaged by the light. So if we are talking about light, it means in reality we have two type of light. We have we have first the insolation light. So this is a light that come from the skylight here, and so this is and then we have the reflectance. So it means depending of the color of the ground, it will, if it is black, it will absorb everything, and if it is white, it will reflect a lot. So it means you can double the quantity of light by using a white floor, or you can decrease intensity of light by having a black surface, and then in between you have a kind of gradation. So from that we made an analyze, a solar analyze of the incoming light inside the space. And we can see, we did this is like in the morning, so we can see in blue, this is where there is more shadow, and in red it's more light, and yellow it's very bright. And here, of course, the sun is on east, so this is why the wall is creating some shadow here. And so at noon, it's more like that. And in the afternoon, it's like that. So the average of the light, incoming light inside the space is these things. And from that, we transform it into line. We follow the gradation, the gradient light, where it's very yellow. Okay, it's become that, and then lighter, darker, black, in the dark area. And that, it's we transform the type of the floor, that can, where it's very bright, we can have a lot of light, and we can increase the light by adding a white floor. And when it's dark already, we increase the darkness um, by creating a black floor. So this we transform into line, and then we have the section of that. The section also, the wall also are taking the same principle of color. And this is some view of the space at the end, with this variation of light linked to the different type of color of the ground. So it was, in reality, it was quite strong. It was, it became very bright when it's white and it receives some light, and then and it was also working from a thermal point of view. It was not really what we want, but it was really also interesting. It was like a little like going under the sun and going more in the shadow. So it was like creating a kind of natural landscape with different light quality. And then all the artwork have different type of quality of light that is corresponding to the artist will, or to the type of material. Another point that is because here I was talking more about form, how to design the form of the plan or the section linked to meteorological phenomena. Here it's we are also working on the choice of material linked to some climatic value of the material. I think it's something that is quite interesting today. And here it's about effusivity. Effusivity, this is the exchange of heat, of energy, of heat between one object and another. And when you touch, depending on the effusivity value of the material, you will lose more heat to the material, or you will receive, or you will keep your heat on yourself, depending if it is high effusivity or low effusivity. And this is a real exchange. It's a sensation when you touch steel, for example. You feel it cold, but you are really losing because the exchange, the temperature of your skin is 34 degrees Celsius. The temperature of the steel is maybe 20. And so because of thermodynamic exchange, it's sucking your heat to the material, and it's really cooling your body. So in this project, we won the competition for public based in the National Radio building in Paris. This is we are in charge of this area that is transforming into a public space with a cafe and a concert space and a library. And so what we did, we start to analyze we start to think about the cafe. We say, okay, the cafe, where it will be good to place the cafe. So and we were thinking that, okay, during the winter it's good to have sun. You prefer to go in a location where you receive some sun. But in the summer, when it's hot, you prefer to go in the shadow. And so we say, okay, in reality, the cafe cannot have a single place. It should be a gradation of atmosphere. It should be, okay, a location, a hot location for the winter, and a cold shadow location for the summer. And so we made the average of the light, also the incoming light in this space, and then from that we transform it into some line, following the geometry of the building. And then we start to create some different area. So the space is defined by following the different, this is where it's green, it's more light than where it's blue, where it's more shadow. And then we transform this line, this form, into the choice of material by saying, okay, in the winter, where there is some more light, I want to have some material that are more low effusivity material. And in order that I can keep my heat on myself. And in the shadow area, I will use a more high effusivity material for that. So this is the choice of the material we have. We create this gradation between metallic and stone and wood and wool. And of course, when you touch wool, you know, you feel it warm, and when you touch steel, you feel it cold. So this is the decision of the material, and this is quite interesting because if you look to the history of architecture, you can understand that, for example, the choice of marble in the Italian church was also a decision of cooling, you know, by effusivity. So this is a plan. You can see the form of the different area that are following the light distribution inside the space, and each line corresponds to one material. So this is like the wool, and then the wood, and then rubber and stone and metallic material. So we can see now some image of the project with this wool area and wood. And then we also decide, okay, this is this with type of furniture that is protecting furniture, and then you move to the stone area where it's less light, so you are more in the shadow, and then you find the most colder area in the steel area. So so what is important is that the decision of material, you choose a material linked with this capacity of cooling the body or keeping the heat of the body to the. Now I can talk about conduction. Conduction is more linked to thermal insulation, but it's also you know the today when you are talking about a wall between inside and outside, you know, before it was one material, but today it's no more one material. It's made of there is some thermal insulation, vapor barrier, rain barrier, or load bearing structure, or a screen, some physical barrier. So in reality, the wall today is composed of lot of layers. And what we propose in this building is to normally everything is together, and you know, it's inside and outside. And here we propose to split the space, you know, to create some space in between. So this is a little to start to inhabit inside the different layer, to find in between the waterproof and the thermal insulation, or in between the thermal insulation and the load bearing area, load bearing wall. So this is like we can see the different layers that are splitting and creating space in between. So this is like living inside the thermal insulation, or inside of between the vapor barrier and the thermal insulation. So here we can see all the layers together, but then here there is only the grid that is a kind of physical barrier, and then the waterproof, and the thermal insulation is creating a space. And then we have here the concrete wall that is supporting all the building. And of course, when you are opening some space in between, but you can create in between the physical barrier and the waterproof, you create a courtyard. And in between the waterproof and the thermal insulation, you create some space that will be not receiving air conditioning in Taiwan. So it means it will be only natural ventilation here. And then the air conditioning will be only in the core of the building where there is a thermal insulation. So we can see it from a construction point of view. Here we can see the grid and the waterproof, and then here the thermal insulation here that stop here. Here the waterproof is continuing, you know, and so we are in between. And then the detail is like that. We have the physical barrier, the waterproof, the thermal insulation, and then it move, you know, it move each from each other to open some space in between. So the first layer is a waterproof, but it's also a kind of sunlight barrier, and we choose it with the albedo, capacity, so it's a white in order to avoid the overheating made by the sunlight, and we can see the building now with this white surface that is reflecting and with this high albedo, and then we go inside the waterproof. And we choose also the material linked to emissivity, because the aluminium here is not emitting some infrared radiation, so it stays cool when it's warm, the temperature of the air. This is what we can see here. Yeah. And then here we are in between the waterproof and the thermal insulation. So this is all the corridor. So it will be not, because it's a building made in Taiwan, so in a tropical, hot and humid climate. So it will be not very comfortable here because it's warm. The air is warm, but there is only natural ventilation. But you don't stay a lot of time inside the corridor, so we can accept to decrease the consumption of energy and not to heat all the toilet, the storage, the corridor, the entrance, all the space where we are not adding a lot of time. And then here we are entering into the thermal insulation inside the building. And in this building called the Climatorium, we have 3 rooms, the coolium, the dryum, and the clearium. And these rooms are taking this issue of climatic issue, about heat, about temperature with the coolium, about humidity of the air with the dryum, and pollution with the clearium. And so what we propose is to have some kind of public space, because this building is a visitor center of the park. So it's become a kind of museum of climate, or conservative of climate, but it's also a public space that hosts, some space where you can go inside when it's too hot outside. It's a little, it have the function maybe of the swimming pool, or the church when you at the basilica time, it was some cold space when it was too hot outside. And so for the coolium, we propose to reproduce in real time the climate of the mountain in Taiwan. So by reproducing the light and the temperature of the mountain in real time. So it will be very cold inside this space when you will enter the space. In the dryum, we propose to reproduce the dry climate of the most dry day of Taiwan. So it's more in November. We can see it here. Yeah. So so this is like a never-ending day. So it's mean we propose to have a floor with a glass floor, and we do the sun pass of the 21 of November, when it's more dry, and when it's more dry, you can sweat more and you can cool the body by sweating more. So this is like reproducing every day the same day of the 21 of November that if you come at 6 in the morning, it will be only this light. At noon, it will be like that, and if you come at midnight, you will through the planet is transparent, and you can see the midnight sun through the glass. The last room is a clearium, and here we produce the temperature and the pollution, the air quality of Taiwan, of Taichung, without the industrial pollution, without global warming. So it's been 1 degree less, because the global warming today is 1 degree more. and without PM2.5 pollution. So this is some view of the building. We can see here, this is the dryum, here this is a coolium, and here this is the, the clearium and the coolium here. Now I move from this from the architecture scale to the urban scale. And first, I want to introduce the condition of today. The problem of the city today are maybe there is three problem linked to. The first one is the urban heat island effect. You know, there is some heat wave, and it's becoming more and more hot inside the city, and because of the albedo, because it's overheating, you know, because of the darkness of the road, and so it's very warm during the summer inside the city, when it's more cold in the countryside. So this is something that is becoming more and more important because of what's happened last year or 2 years ago. It was very hot during the summer in the city in Europe, for example. Then there is some flood problem, you know, the link to global warming that is increasing the water trouble, you know, by increasing of by the we can see that there is an increase of the flood trouble. And then there is a PM2.5 pollution, you know, this emitted when you burn some fossil energy. It's produce CO2, but it also produce PM2.5 fine particles that are cancerinogenous today. We know that it's and this is also a fight to decrease, you know, the PM2.5 air pollution. So what are the means for that? It's still some climatic tools, but it's also some ecological tools in this case, linked to convection, albedo, effusivity, evapotranspiration, or air phytoremediation or water management. So now I want to present the park in Taiwan. So the park is a competition we has won in 2011. So it's on the site of the old airport. It starts from here and it's finished here. And so this was at the beginning of the construction. So the master plan is based on convection, but because we first when we start to design the project, we talk about what is the role of the park, because the climate in Taiwan is hot and humid. It's a tropical climate. So how to decrease the temperature, and how to maybe deal with the humidity of the air and with the pollution. So this was these three layers we used for designing the park, and in reality it was also something quite traditional, because at the Haussmann period, for example, for Central Park in New York, or in the big park in Paris, or in some other old the city, it was made also for cooling and for cleaning the air. It was not working, but for cleaning, but it was the idea. So we came back to this idea to deal with heat, humidity, and pollution in order to give to the people some comfortable space. So this is the master plan, and this master plan is made with these three layers: the heat layers, the humidity layers. Layers is in red, humidity layers is in blue, and pollution layers is in gray. And so the first layer is based on convection. What we have worked with Transsolar, the German from Stuttgart company, to do a CFD, computational fluid dynamic model, to see where it will be more windy inside the park, because the temperature, when you feel it warm, it's depend of different factors. It depends of the temperature of the air, the humidity of the air, the direct sunlight, the emissivity of the material around you, and it's depend also of the wind, because when it's more windy, it's less comfortable, because it's like blowing on the soup, like or blowing on your skin. You remove the heat of your skin, and so it gives a freshness feeling. And so all the parameters are the same except the wind, because we have a wind that is coming from the north that is entering the park. And so from that we map where it's more windy in red and less windy in blue. And so from the wind map, we create the composition of the plan with like a natural condition that will be more windy here in the future, because we place all the future building of the new district. So the park is 70 hectares and the new district is 270 hectares that will be built around the park. And so we can see here the cold area and the warmer area, with this gradation. And then we materialize this map, this form, with the trees, so we can see the gradation. So where here there is a lot of trees every 3 meters, so it becomes like a forest, and then there is less trees. And of course here it will still be warm, when here it will be cold, because of a double effect of cooling by wind, by receiving the wind, and cooled by the shadow of the trees. And then we create the cool path, that connect all the cold area, and the activity also follow that. So it's why a little, I say it's no more form follow function, but it's become a function follow form and follow climate. First we design the climate, we analyze the climate, we design the climatic form, and then we find the form, and then we place the program. So this is a kind of a different step of design. So the type of trees is also linked to climatic issues. So we are choosing some trees with a lot of leaf or big leaf in order to reinforce the cooling effect, the type of ground. And so this is like the first layer. The second layer is based on humidity. So it's of course water management. We have to deal with all the water that is coming. So all the topographic, because it was a flat site, because of the airport, and so because of that, we need to manage the rain, and so the topography is a consequence of the rain management, because you dig in order to create some basin to receive some rain water, and so it creates a hill, and so all the topography is linked to that. So we can see the process of that, and this is what's happened in the in the in the park. And this is some different situation when there is some rain, or a lot of rain, or heavy rain. It's the park can be flooded by the water. We can see the park, it was last year, so it's already done, and we can see after a heavy rain here, we can see that the part of the park can be flooded by the water. So the park is working like a sponge also for the rain trouble. Okay, we on the same layers, we are working on the on the type of ground also, linked to the dryness by using some dry ground. So here we can see the second pass, that is a dry pass, that is that connecting all the dry area, and that will be we say it's a sport pass because you can sweat more, and so it's more comfortable for doing sport. The last layer is about pollution. This is there is some big road that are near the park and passing through the park. So of course it will be more polluted close to the road and less polluted far from the road. And so from that we say, okay, here this is a cleaner area and the most polluted. It will be more silent, the air will be more clean. And we reinforce that by placing a lot of trees that have the capacity to absorb the air pollutant. So there is some few specific trees that can do that. And we can see the location of the trees in the less polluted area. And so then all the children activity find place in this more quiet area and less polluted area. And the path, the clean path, is very flat, and it's like for bicycle and for baby car. So we are always in the composition way, we are always working by gradation. So here it's less polluted and more polluted, and here it's more polluted. It's always creating some diversity of things. So here, this is all the trees, the cooling trees, the drying trees, and the depolluting trees, and all together it creates different microclimate where it can be cool, humid, polluted, or cool, dry, clean, and so the idea is not to create an homogeneous space, but to give different qualities that can be, so everybody are free to decide where they want to go, and also depending of the time of the day, of the year, at 6 p.m. in the winter, you prefer to have a little more sun, and at noon, you prefer in the summer, you prefer to be protected from the sun. So this is some view of the park today. We have 20 different pavilion and toilet and devices and building. Now, very quickly, something about the meteorological garden. This is an area where we have some devices that are cooling by convection, by evaporation, or by radiation, and I just show some of them. We have this anticyclone that is cooling by blowing cold air. All the energy of the park, we will see that after, it's produced on site. And here we propose to blow some cold air by using geothermal cooling. So we take the air from outside at 32 degrees Celsius, for example, and then it goes down where it's 25, and then we blow some cold air by using geothermal cooling. And so this is like a kind of pavilion that is creating a kind of microclimate where it will be a little colder than outside. Another is by evaporation. Of course, it's with by spreading a droplet of water that evaporate, and by evaporation it's take the air, it takes it reduces the temperature of the air, and then it cooled the air. Another part of the park in Taiwan is this faded exterior. We, at the top here, we have 7,000 square meters of photovoltaic panels that is producing. We have also 3,000 down on the south, and it produces all the electricity of the park. All the energy is made on site. We don't use something else. And we create a large canopy of photovoltaic panel where we can find under some building and some landscape that will be also under that. We can see this sky that is reducing the quantity of light that is very hot, very strong in Taiwan. And we have this new landscape behind that with some building there. I'm using sometimes some Instagram photo because okay. And just to say that we also propose to have an app for the iPhone. We have every 50 meters, we have a sensor that is measuring the temperature, the pollution, the humidity. We can see this here, the sensor. We can see them. And so with all these sensors, we can recreate a kind of climatic map in real time, like a meteorological map that will change every minute, you know, and that can show where it's more polluted, less polluted, or more hot, more humid, and that with a kind of index. And this map, we have an access by iPhone, by a smartphone, where we can see, and we can decide where we want to go by following the map. And I will finish with the last project with for Milan. We made with OMA, and we won the competition in 2019. It's for two parts of Milan, one 44 hectare and one 15 hectare on the south of Milan. So the idea of the project was to think about, because this is new district, and to think the new district linked to, you know, when you design a master plan, you have, of course, a building, but you have also some public space. And the idea is to reinvent in a certain way the public space by creating a kind of environmental space that have a function to be public, but also to have a function to have something on the environment quality. So first we have to know that in Milan it's polluted and it's hot. You know, there is a wind coming. The most common wind come from the southwest, and this is some measurement one day. You know, it was very hot. You know, the wind arrived. It is a little colder, and because the city is very hot, you know, it start to heat the air, and it's become more. You go on the east, and on the north more. It become warm, and this is linked to about pollution. It's the same effect. The pollution is produced by the car inside the city, and then it moves with the wind, and so we can see in this that red is very polluted. So you see Milan, and you can see that the wind take all the pollutant with that. So it means the south west area is less polluted. The air is more clean than here in this area that is more polluted. So the project, the base of the project was to create these two large public space. We called them the limpidarium, so that an effect to be public and to also to clean here in Farini to clean the air of the new district, and in San Cristoforo to clean the water. So this is this new public space, and we call them the limpidarium. So it's mean the space that is cleaning, and this one is cleaning the air, and this. Okay, so so the idea how to cool the city, the idea is to cool by convection, by creating a wind between the cold area and a warm area, and also to work on the albedo, you know, where it's maybe where it's more black, it's heat more, and where it's more white, it's reflect more, and so this is some different strategy we made there. So this is something just to for the building of Farini, we propose to have a white surface. The horizontal surface is more white, and then if you have also the white vertical surface, it's not so good because in reality, we can see here it creates like it bump, like bomb, and so the sunlight will go down and start to heat the street. So we create some trap, you know, black area or more darker area at the top of the building in order to block the heat at the top of the building, and the heat can be removed by the wind there. So this is this different effect, and then this new wind, this convection wind, can move through the new building. So this is a model. Here we can see the new district that is here with all this. So it's parallel to the air, parallel to the wind, all the new buildings, so all the air can move through. So here, this is a limpidarium d'Aria. So we can see this cold area that is produced by water, by evaporation, and also by the shadow that recreate a kind of new wind that will, by convection between the cold area and the warm area, that will cool the city by going there. And then we have an effect on the pollution that is trapped by different. The PM2.5 is trapped by also by creating an artificial rain that go also when it's very polluted. We can fall down the PM2.5 with the rain. So this is a little the principle of that. So so we have this new district, you know, with this limpidarium and this new building that are also letting the air going through here. And the second district is San Cristoforo. Here we propose to create a limpidarium d'aqua. So the principle is this one. So we, because in Milan you have a lot of underground water that is can be dirty, and so we propose to have a kind of filter that is cleaning the water by phytoremediation and creating a public space based on the water that can be a kind of a natural swimming pool. Okay, thank you.
All right, thank you very much. That was actually really, really interesting and really enjoyable. I want to open now the discussion to everybody who has a question. You can write it either in the chat or just put your camera or your microphone on and talk to us. Well, if there is no question yet, I have a question actually. You showed us very interesting charts and everything about how to like let the heat and keep the heat in and keep the heat in the house. But I mean, facing climate change will probably have more of a situation, not exactly like Taiwan right now, but it's gonna be warmer and warmer, and at the end it's not gonna be the biggest problem to keep the heat in, but to keep it out. And I mean, also the other building you had with the circle, there are different sections, but they don't work at both times of the year. So the stone section is not going to work in winter,
Yeah.
will it?
Yes. No, I think it's yeah. So for the first problem, it's yeah, we are they are talking about maybe you know, in Geneva, for example, they are saying that the climate of Geneva in you know at 2100 will be the same than on the south of Italy or on the in Les Pouilles, Puglia, you know, and so you are right that you know the summer conditions are becoming very very important too. This is true that today, you know, in Germany or in Switzerland, you know, the average of the temperature is around 10 degrees Celsius, you know, if you add all the months together. So it means there is more months where you have to fight the coldness and in the future, maybe it will be, okay, 14 or 15, maybe, you know, so it's mean, it's true that we have to think for the winter and for the summer and but for the summer maybe yeah, so it's absolutely true that we have to think with that. And then but maybe this question is also linked to the second question about you know what we are placing, for example. I think when we you know, we are creating some condition of different, okay, here it will be more warm and here it will be more cold, but in reality these conditions are like a background, and then it means you are free to decide where you want. Maybe it's a rainy day, so you go there, it's a sunny day, you go there. So it means it just you know, it's because I'm pointing this question of quality, you know, if you are close to the window or far from the window, you know, it changes in all the situations. So we are just pointing this question, creating some quality, but after you are free to decide where you want to go, and you know, it will be also so it's mean the in my you know, this is also a kind of philosophical point of view. I mean, during the modernity, during at the beginning of the 20th century, you know, we were like in the functionalist point of view. You were pointing one good solution. You know, okay, this is good and this is bad. So you are doing the good things, the good. But in the postmodern period, we know that this is also maybe linked to post-colonial studies and gender studies. We know that, okay, there is not only one solution. There is a diversity of solutions. You know, the diversity, the multiplicity is also becoming important. So in all our projects, we are never creating only one solution. We are always creating gradation of solutions. So it means, and we are never saying that the bad solution is bad. You know, in Taiwan, we have some areas that will be super hot at one moment. So of course it will be very uncomfortable, but we keep them because maybe someone like to be there, or maybe you know, in December you would like to be there. You know, so it's just to offer some different to offer some different quality, and this quality are you are always free to move through this quality like it was, you know, Palladio, when he was designing the Rotonda Villa, you know, he was creating four sides, but he said that, okay, the north side is for the summer, the south side is for the winter, and so the people can move in the house depending of the moment of the day. So this is why my work is not a functionalist, neo-functionalist. It's integrate this diversity and multiplication. So it means multiplicity. So it means it's offer always gradation of conditions. So it's why sometimes it's work exactly as I described, but sometimes not, but it's just the conditions that are changing, but this is like what's happened everywhere, always. Yeah.
Well, thanks. Does everybody from the big round has a question?
I have a question.
Yes.
Actually, my question maybe not so high level. It just had something to do with my studio, my study, because we in the normal architecture studio, architecture school, I'm not sure we have this kind of chance to do this climate design, or it's kind of like the true science. I'm very curious, like from when you shifted your direction to this climate design, and also I want to know if I, as a bachelor student, because I even in master students' work, I rarely seen this kind of design in this master students' work. And also, so the second question is, how can I get these inputs and let myself equipped with this technology, this ability to better to react with this real world?
I think first we in reality what I just opened an exhibition in Paris called Natural History of Architecture. There is a book, but it's only in French. But and it's about the history of architecture. And in reality, when you are saying that today you are not learning about climatic things, in your studio, I think it's a consequence of the postmodern period, because it's linked to oil and antibiotic in reality. In the capacity of the oil completely changed the way of designing the project. Because, for example, the dome. If you take the Pantheon in Rome, you are in the Pantheon in Rome. This dome. You have a hole at the top.
Oh yeah.
And, yes, this Roman structure. And this was made also for evacuate the hot air, because the air was warm and go out, and then there is a hole, and so it can go, and so it cools the space. And Palladio explained that, or Alberti, during the Renaissance, they explained that they are designing linked to that. Alberti say, okay, in the summer or in Mediterranean climate, you should have a high ceiling because it will be colder. In Germany, you must have low ceiling because it will be warmer. So they explained the size of the room linked to climatic issue. And we completely lose that from 1950, or maybe before, from the beginning of the 20th century, because we were using coal and oil. And because of the power of this fossil energy, we don't need anymore to all this form of architecture. We just turn on the radiator, we burn massive energy, and we use air conditioning, radiator. And so all this, the fundamental reason of the form of architecture disappear. And we start to think about architecture from a cultural point of view, saying, okay, it's linked to the prestige of the form or the cultural value of that. But it was in reality not exactly like that before the 20th century. So I think today, because of the global warming, but also because of the virus epidemics of today, all this reality is coming back, and we can, I think, this is something that is becoming so important today, and we have really to re-engage all this type of things, you know, for designing architecture. And from my point of view, you know, this is something that I'm working since many years on this issue, because I know about global warming, and I think we know that it was a very crucial problem, you know, that was, you know, because of the building is producing 39% of the CO2. So it means, and so from my point of view, I start to bring this climatic agenda into the field of design, and so it's my research is like that. So there is some book that I have published on this type of work. There is a yes, a book in English also that called Constructed Atmosphere, that is just republished in a black and white edition, but it was sold out, but it's just republished. And then the second question, yes, I think I have answered to your question.
Yeah. But yeah. Yes. Thank you.
Maybe I have one more question. First of all, thank you for the very interesting lecture. And we from Skizzenwerk should send you some greetings from Anne Lin, who held the lecture 2 weeks ago. My question is about your practice, and I wonder how, if you do a competition, how do you analyze all the different meteorological circumstances? So you showed a lot of diagrams, and for my perspective as a student, it looks very difficult to visualize all these circumstances and to get the information.
So the first information about the climate of the city, of the area, you find it very easily today, you know, on the so there is some weather website with a lot of sensor everywhere in the world, so you can get all the average of temperature, of humidity, of pollution. So this is something that there is a lot of monitoring of climatic monitoring everywhere. So you find the information about the temperature, humidity, and wind, and pollution. And then what we are doing is yes, we are using this. There is some software, you know, and there is some free software you can find on the that are made, you know. So normally in the sketch design phase, we are more using like some software we have, and then you know, for the park in Taiwan, for example, we work with an engineer company, you know, for doing the real model, and to have in order to calculate the flow of air, for example, the quantity of air, the speed of air, and this is the tools, these kind of computer tools. You know, you have tools for the for the air movement. So this is like what we call the computational fluid dynamic, CFD model. There is one from the Autodesk. They are doing it. I think it's called Climate. For the light, we were using like Ecotech or some other, but it's no more there. But you know, you can map, or you can analyze the light distribution, and so this is and then of course more and more we are working on that. More and more we understand a little the phenomena that are engaged, and also what is good also today, we have the access, you know, on the academic papers that are made on research, and this is quite, you know, you go on Google Scholar or some other things, and for example, it's quite good because you can, for example, the tree phytoremediation, you know, it because sometimes you heard that okay, trees is good because it's clean the air, but in reality, you know, there is some analyses that are made, and 2 years ago, there is a very large and important analysis about the trees and the capacity to catch the PM 2.5 pollution, for example, of the air. And they find that only the pine trees have this capacity, or very specific hairy leaves trees, but the other have no capacity to clean the air. So it's also important to work with science. I mean, to work also with the university papers, and this is not so difficult today to find the last result. You know, you can because you can see, and this is a little how, you know, to learn and to and to yes, more and more by being curious about different phenomena.
Thanks.
All right, is there any other question? Because if not, I had to think about something when you said that you could just switch through the zones from your buildings and choose where you are. But I thought, so last week's lecture we had Mariana Popescu, and she also mentioned some real interesting facts about climate change, and she said that we need to build, I don't know the exact number anymore, but a lot of New York cities in the next few years to occupy all the people that are going to be born in the next 30, 40 years. And looking at our consumption of space on Earth, we are not going to have the ability to choose between spaces because we don't have the space. So are we going to have to compromise in the future if we say we're not really following form, follows function, follows climate?
I think you know, I think we have you know, when you see that that the building are emitting 39% of the CO2, you understand that, okay, we can really work on that, you know. So and because we are practitioner, we are designer, we are not complaining only, you know, we are doing things. So it means, okay, we can of course change you know, the existing building and condition of the city. You know, this is what's happened in the city. For example, they are changing, they are painting in white the roof in New York or in Pakistan. You know, they are, because to cool the city, or they are doing things about the water, because of to fight the flood. And so we have to place thermal insulation on the old building of the 20th century that are losing so much energy by the not. So I think we as architects, we have really to work on the reality, and we don't have to complain about, you know, about the kind of massive catastrophe, because we can reduce the CO2 emission, and this is our mission. Our task is to do design and to reduce CO2 emission, and so what is also interesting for us is that it creates a new style. So this is a little funny to say that, but it's also a new style. It's a new aesthetic. You know, it's so it's also positive. I mean, so this is what I'm. Of course, it can be worse. It can be you know, a disaster. But it can be also. I have some conversation because, for example, with philosophers that are mixing everything together, you know, because for them it's a big catastrophe. We can do nothing because, but me, I was saying, but yes, you can save the world only by placing, by changing your window, because you have single glass, so you put a double glass window and you will save the planet. But for them, it was crazy to say that, because they but you say, yes, but if you reduce 40% of the CO2 emission, you're already, you are in the French agreement, you know, in the Paris COP15 agreement. So this is what we are doing. We have to be, we have really to be positive, and so this is this and all the problem we have to find solution, and so I understand that of course there is a lot of different things that are coming, and but we have always to be positive in the way of in fighting you know that problem, and to do design that have new quality linked to this new problem. And so of course it will be a change of style, because it will be no more the 20th century style that is coming from you know, a huge amount of energy that was spent, that was used. But today we are using less energy, so it's changed the style of building. You know, it's why there is so much wood building today. You know, because there is a it's changing, and so this is quite interesting for us and for our generation, because it's a new moment of a new moment in at the urban scale and also at the architectural scale.
I find that really fascinating, that we have to also see the positive in it, that it creates a new style, which we can clearly see in your work, which I find so interesting, that you have this really analytic style to say, we take the temperature and this is exactly what we do now. So it's, you can really see what you did with it. I'm again opening for questions from the audience. I don't want to be the only one having this opportunity to talk to Philippe. Because if not, I like to ask my last question. It's kind of a funny question, because it is well, it is not really answerable, but I like to ask it everybody who's in the business of sustainability. So everybody, do you think it's going to work? I mean, you talked about the Paris Agreement, and how is it looking? We have all the tools to make it, because the world is going to survive without us, but the humans are not.
Yes.
So you, as a part of the human race, do you think we're going to make it? Because at this point, it's not really looking like it.
Yes, yes, I think, you know, if you look, this is also my history of you know, the exhibition of the Pavillon d'Arsenal in Paris, and the book Natural History of Architecture. You know, there is some change. For example, you know, I mean it surely it will create a lot of social trouble, and you know, maybe war and things like that, because you know. Okay, so yes, sorry. Yes, so yes, what I was saying, it's in the history of architecture, you can find, for example, you know, there is some change of location of, you know, the Viking, the Norman capital was very on the north, you know, when it was during the Middle Age, because it was a warm, it's called medieval warm period. And then there is a little ice age that starts at the 14th century. And so the court of the Vikings start to move to the south. They move to Copenhagen, you know, and so the city location changed, because if it was too cold, it was also the reason of but so it means in the history there is some change. I think what was the problem today is like the model of the industrial emission of CO2 doesn't work anymore. So this is a new model that have to come, and maybe it will also recreate a kind of partition of the people on the earth or things like that. But of course, we have really to at the end, the human will be still there, I think, in 100 years, but maybe the problem will be all the war and the social trouble that will be in between. And so it's why we are really to do our job, you know, from.
So you think we're going to survive, but it's not going to be fun? Is that what you're saying?
Exactly. I think, yeah, but yes, I think, but we have to do the best now. I think it will be, yeah.
And that's true. I mean, if everybody did work like you did, I'm not gonna say that just like that, but if everybody tried as hard, I think we have a shot. And this is, I think, the end of this lecture, and we can leave everybody. Oh, there is one question, I see. Okay. One question from the audience from the chat. What are your future projects?
What? Sorry?
What are your future projects is being asked in the chat.
The what? Sorry?
Your future project, what you're going to do in the future.
Sorry. Now I'm working for a company building near to Paris, like with a kind of it's a kind of market hall plus the office of a kind of company that have a lot of shop in France, and we are working also on the project in Iraq, in Basra. We made a new master plan for the port of Basra, because that would be that is also based on a kind of large canopy. We call that the shadow kilometer. We create a kind of public space of 1 kilometer of shadow that is that's becoming a public space where the new building can be organized. And also we are doing a competition. We are on the final round for a very a good important competition near Paris. So this is what we are doing now.
That seems really nice, especially the 1 kilometer of shadow was kind of a nice catchphrase. I think now is the time to say goodbye.
Thank you.
Yes? Oh yeah, well, thank you very much for being here. Thank you everybody for listening and for being with us the past 4 weeks. We had a great time. It was real fun. And we hope to see you soon in the next summer.
Okay. Thank you very much. Bye-bye, everybody.
Goodbye.